Let's practice drawing a Bohr diagram. We're going to take a look at this example from our handbook. This is the last diagram of this group, and so it'll be a good workout for us. In this video, I'm going to encourage you to go through each part on your own, and then I'll ask you to stop the video, try it out, and then you can check against what I've drawn. So this will be really good practice for you. Let's begin by identifying this element. So it's the second element in the fourth row of the periodic table. So we can go down to periodic table chart in our handbook and we say, okay, that looks like calcium. It's element number 20. So let's start to fill out the information for calcium. So first of all, let's figure out the parts of this atom. I want you to write down the number of protons, neutrons, and electrons in this atom. So take a look. We have the value of its atomic mass right here in front of us. Do that right now, and then we'll check your results. Pause the video here. Okay, let's take a look at the parts of this atom. So the atomic mass is 40.1, and the atomic number is 20. So that means there'll be 20 protons. For the number of electrons, we have to do 40.1, which we round off, minus 20. So we have 40 minus 20, and that gives us a result of 20, meaning 20 neutrons. And because the atom is electrically neutral, it will have 20 electrons. So let's start to fill this in. Make sure you've already written this yourself before you take a look at what I have here in the video. So if you need to, please pause the video here. Okay, let's write down the name of this element, its symbol, and its atomic number in the top of this spot. Again, pause the video here, try this yourself. Okay, now it's time to start drawing our Bohr diagram. So in total, we're going to have 20 electrons in this atom. And following our usual rules, we always start from the orbitals or the shells that have the lowest energy. That means the ones closest to the nucleus. So in our first shell, we can fit a maximum of how many? 2 electrons. Fill out this shell, do it yourself. Pause the video now, and then you can check your work. Go. So in the first shell, we draw 2 electrons, which looks like this. Great. Now we're ready for the next shell. It can hold a total of 8 electrons. Pause the video here and draw the electrons in the next shell. Go. Let's take a look at the second shell. There are 8 electrons in total, and so we're going to end up filling up this entire shell. So I'm being sure to show the electrons pairing up. And let's do a quick check. How many electrons have we drawn in total? 2 plus 8 is 10, which means we have 10 more to do. Okay, let's draw the electrons in the third shell. Pause the video here, and then you can check your work. Go. In the third shell, we can put a total of 8 electrons. Let's draw those now. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, let's check our total. We have 2 plus 8 plus 8 electrons drawn already. That's 10 plus 8, 18. In total, we need to draw 20, which means we have 2 more electrons to draw. In this next shell, we can draw those 2. Put those there. And now we are done. We can do a quick double check. We can count all those electrons. So 2 in the outermost shell, 8 in the next one, that's 10. 8 in the next shell, that's 18. And 2 in the innermost shell, that makes 20 in total. We can double check the number of particles in our atom, 20 protons, that agrees with the atomic number for our element, 20. And so it must have 20 electrons since it's electrically neutral. The atomic mass was 40.1. So if we do 40 minus the 20 protons, we get the value of 20 for the neutrons. And so it looks like we've done a good job